Hi, before we start, let me guess something. I think you are a student, you are involved in Formula SAE competitions, and you are looking for some ideas to use in your project. Am I right? If yes, so let's proceed because I think you found the video you were looking for. But if you are not the guy, then let's proceed anyway, okay? So what's it? What's this PCB that you are looking in your screen? So basically this is the final product of my thesis of electrical engineering course that I'm finishing right now, and this is basically a solution that we found to control the torque of our electrical vehicle. What was the problem? The problem was that we didn't have an electrical control unit to calculate the torque that we wanted for the vehicle. So basically we had the acceleration pedals connected directly to the inverter, and the inverter was not so flexible, so we could not edit the software inside it, we could not calibrate too many parameters, and then yeah, we found out that we needed a VCU. So let me start showing you a diagram that I have here to present the hardware. Yeah, so basically we have a microcontroller, that's our brain, yeah, and I'm using ESP32. For this microcontroller, we have some inputs and some outputs, right? So analog and digital inputs, outputs, sorry, and some CAN nodes that could be inputs and outputs as well. So the main signal of our microcontroller is the torque signal, and it's going in a CAN signal to the inverter. Okay, and also we have some circuits here to reduce the volts that's coming from the vehicle, yeah, from 12 volts to 5 volts or 3.3 volts. So to use in the microcontroller and the peripheral components. Okay. Yeah, so all these circuits I have implemented here in Altium Design. So all these files here will be available for you. I will paste the link here in the description, and also I will be very quick here because the idea is just an overall picture, because in all the details you can search and you can send me messages if you have doubts. Okay, I will let my email below and you can feel free to send me messages. So first of all, we are reducing the 12 volts to 5 volts with a bucker circuit. Then we are reducing the 5 volts to 3.3 volts. Here we have the basic circuit to make the ESP32 work in a standalone mode. Yeah, so here's the microcontroller, and in the right side we have a circuit to flash the microcontroller. So basically here we have a micro USB connector that will be connected to the notebook or the laptop, the PC. And here down we have a logic to make it more easy to flash the microcontroller. Because if we don't have this logic here, then we need to use push buttons when we are flashing the microcontroller. And with this transistors here, then we don't need it. Okay. Here we have basically all the inputs and outputs of the VCU. So for the analog inputs, we have some low pass filter to reduce the vibration in the signal. For the digital inputs, we have a voltage level shifter, so we are changing to 3.3 volts, then we can read the signals inside the microcontroller. And for the outputs, the digital outputs, we are doing exactly the opposite. So we are converting from 3.3 to 12 volts in this case here. Okay. Here we have the two nodes. So this microcontroller doesn't have CAN integrated. So we need to convert SPI communication into CAN communication. And that's why we have these circuits here. So they are like two broader circuits. They are exactly the same. The only difference is because they are using two different SPI connections into the microcontroller, and that means that we can use two different baud rates for these CAN nodes. That's very interesting. And then we have the general connector of the ECU. Here we have the footprint part. Yeah. So here's the top layer, bottom layer, and the 3D model. Yeah. So the idea is take a look in my project and do your own project. Okay. But if you want to let's say save time and make a first prototype to validate something, then you can take my project and use the way it is. Okay. No problem with this. Okay, so let's take a look now in the software, the firmware itself. I did the firmware using MATLAB Simulink, and I hardly suggest to you to do the same, because when you use the module-based strategy, you win a lot of time, because you don't need to waste time thinking about the code itself. You just think about the strategy inside the software, you know. So you go here, you draw what you need, you add this embedded software, embedded coder add-on. Here you generate the code will magically appear here in the right side, all the files you need, the libraries and so on, and you can go directly from here, flash your microcontroller. So that's very easy to use. There's a lot of tutorials in the YouTube and internet in general. You can take a look. Okay, yeah, so this is the idea. I designed it here 6 blocks. So first of all, we have a block to data acquisition, then we have a safety check, we have a powertrain, we have a cooling system, we have a gear shift function, and then we have the output that will export all the signals from the ECU. Okay, first of all, we receive all the signals from the pins, then we have some calibrations for the signals. So we have analog inputs, digital inputs, CAN inputs. So we convert from 0 to 4000 and something, for example, in 0 to 100%, and then we can use this signal further in the software. And we have some debouncing logic. Every logic that we need to treat the signals we do inside this block. Then we export the treated signals. We go to the safety check. Here in the safety check, we have both signals of the acceleration pedal. We have some filtering. You have rage check and consistency check. Then we also check if the brake pedal is pressed or not. If the brake pedal is pressed together with acceleration pedal, then it's a problem. And then we need to set a fault, or we need to set the acceleration pedal to 0. And then we have a saved treatment in this case, you know. This is basically what this block does. Forward here we have the powertrain block. Here inside I defined 3 different drive modes, and here we can calibrate different torque maps for each one of them. So for example, here the normal mode, we have a map that we can calibrate any way we want, and the same way we have calibration for the other models. Okay. Also we have traction control. So basically we check if the vehicle speed is 0, for example, but the wheel speed is not 0. That means that your wheel is spinning and the vehicle is not going forward. That means you lost the traction. And then we set a flag. With this flag, we are triggering a curve that will reduce the torque in the end. And reducing the torque, the wheel will reduce the speed, and then the vehicle will retake the traction. And then the flag will be false, and this curve will invert and will start to increase the torque in the end. And in the end, we'll take the torque, the original torque again, after the traction is retaken. Yeah. This is a very, very quick explanation. Okay, you can take a better look later. We also have a function here to check any temperature that we want in the vehicle. We calibrate a value here. If the sensor exceeds the value, then we set a digital output that can turn on fan or a pump inside the vehicle or something to refrigerate the system. We have also a gear shift that is looking to the RPM signal. If the RPM is more than something calibrated, we are generating a pulse. This pulse will blink a LED, and this LED will be placed next to the driver, and the driver will know the time to change the gear. Okay, so and in the end we are exporting the signals as digital outputs or CAN information. Yeah, I think this is a very, very quick explanation. I think you could take some ideas. Also here, a good hint for you is to create like a panel, like this one that I did here. You can link these buttons here to variables inside the software, and you can simulate all the system. So for example, here for the acceleration pedal one, I didn't have the potentiometer or the vehicle to test at the very beginning. So how could I simulate the system? So I created here a selection. Yeah. So I select that I want to use a system constant. This system constant is linked to a button or something here inside a pedal control. And in the end, when I generate the C code, all this part here of simulation, buttons and so on, they are not involved. So they will not appear in the C code. And that's all, folks. I wish you a very good luck with your project. I hope you can get some ideas from here. And if you use my project, then put my name there or send me a message, email. I would like to know that someone is using my project and I don't know, in different places, different countries, different teams. Okay, so that's it. Thank you for all and see you next time.